So hey everyone, I'm Arthur Berezin, a Senior Technical Product Manager. And today we're going to talk about OpenStack Platform 5.0 and high availability actually for OpenStack Platform. So probably all of you guys sitting in the room working in your, on your OpenStack deployments, and you planned and you want them to be top-notch performance environments, right? Performance and making sure everything consistently works and running and everything running perfectly is extremely important, right? So who of you actually deployed by himself an OpenStack environment? Please raise your hand. OK, pretty decent amount of you. So you're the guy with the helmet, right? And every inch, every tiny movement of the wheel actually making the whole difference between winning and being that guy finished second or not necessarily even finishing the race, right? So driving a car without your steering wheel is obviously something you would not like to do. Hence, high availability for the controller plane, for your steering wheel, for your OpenStack environment is extremely important and crucial in production environments. But we all know that this is the reality, right? OpenStack is fairly complex, got fairly complex architecture, it got many services, many components, making the whole thing work together as a whole unit. So there are some OpenStack high availability solutions or reference architectures out there. You've probably seen some of them or implemented some of them. And we all know it's fairly complex. So our engineers built the whole OpenStack high availability solution from A to Z, making sure all components are constantly available. And that came out about 6,000 lines of configurations. That's fairly complex, right? So today we're going to talk about high availability components. Okay, the stuff we use, the components we use to make sure OpenStack keeps on running. Talk about the architecture of the whole solution for OSP5, and we're going to talk about the deployment layouts that we are supporting and you'll be able to use. So what is high availability? So first, you would like to make sure everything is 100% or 99.999% highly available and things keep on running smoothly without any issues. And secondly, you would like to make sure everything runs consistently on high scale. So you have a huge load of requests coming in to your environment. Obviously, you would like to make sure you're able to serve that high load. And we want to make everything easy, right? Because we've seen how complex it is. So we've been working on a little project called State-Oft, which is a plugin for Foreman. And that makes the deployment of OpenStack very easy. So we've integrated the whole, we are working at, we're integrating the whole high availability solution for OpenStack within project State-Oft. So I have a little screenshot here. I could not resist putting it in. And that's an upstream project that you can all find on GitHub. So, sorry, battery. I hope it's better now. Sorry. Right. So we have been integrating the high availability solution within Project State-Oft and within Foreman. So we have a single radio button. You just choose, I want this environment, this new deployment I'm configuring right now, I want it to be highly available. OK? You click on Next. On the controller plane, you just choose 3 hosts you want to be serving as your controllers, right? Click the deploy button, and presto. You got everything pre-configured with Puppet manifests, deploying the hosts. We're using Foreman's host auto-discovery, right? So you have all the hosts automatically discovered by Foreman. You just choose them, hit deploy, and you have highly available environment. Well, that's nice and all, but what's happening behind the scenes? So we have to make sure the services themselves are highly available. And we have to make sure the database, our persistent data layer for OpenStack, which holds all the configurations and all OpenStack files and everything, the whole environment actually within the database. And we're making sure that the messaging layer is also highly available. So what components do we use to make this whole thing work together? To make sure that the services run are consistently up and running, we use Pacemaker. We actually construct clusters around each service that serves the OpenStack API. So the services themselves are stateless. We use Pacemaker to make sure everything is working, and to monitor the services and to recover upon failure. So Pacemaker just monitors the services. So if there's a failure, it brings the service up to make it run again. In addition to that, we also use Pacemaker to have a virtual IP. So within a cluster of a service, we use a single IP address that actually resists within one of the controller nodes, and that takes all the requests for that specific service. We also use a HA proxy to load balance incoming requests. Right? So we have high load, high amount of requests coming in to specific servers. This could be Horizon, this could be Cinder, or whichever service from OpenStack. And we use a HA proxy to load balance those requests among the hosts. So those two take care of the services. For the persistent data layer, we use Galera with MariaDB. Okay, so actual Galera is a very cool technology, making sure that data stores are synchronous among the several nodes. And that's a multi-master replication based on a row locking. So it gets pretty high performance. And in addition to that, for the message layer, we're using RabbitMQ with mirrored queues that replicates the queues within the controller nodes that running the RabbitMQ. So let's go through the workflow that regular request comes into OpenStack. So we have our OpenStack Horizon user requesting GUI now, right? He wants to see the GUI. He makes the request to Horizon, which is a single point of failure, and we want to make sure that would not fail. So we put HA proxy in front of it. And HA proxy load balances this request among several nodes. Okay, that could be 3 or more. But now, HA proxy itself is a single point of failure. In addition to that, still, the Horizon services can fail. So for the services themselves, for Horizon service in this particular example, we construct an HA and a Pacemaker active cluster around it to make sure that if a service fails, Pacemaker recovers it, so it would continue serving the requests. In addition to that, HA proxy by itself can recognize that there's a service failure, and it stops serving that load to that particular failed node. So we also construct a Pacemaker active cluster around HA proxy. Make sure that HA proxy itself wouldn't fail, and we use a virtual IP for that particular service, right? So in this case, we have this nice little person requesting Horizon UI. He goes to that virtual IP, which actually resists on top of one of the controllers, right? And HA proxy distributes that request to one of the other controllers running the service. And we do that for all the stateless services that run OpenStack. So we can take a look at another a little bit more complex example, Cinder. Obviously, there's some storage-related service, and it's extremely important to serve that. So in this case, for Cinder, there's a backend storage, and each of the Cinder services has access to that shared storage API, the shared storage backend. The network case is a little bit more complex. Obviously, all of you know Neutron is a little bit harder to make highly available. So for Neutron server, obviously runs on the controller nodes. We also use pacemaker and HA proxy to do what we just described. In addition to that, we have the compute nodes running layer 2 agents. So we build a highly available pacemaker cluster around the layer 2 agents and around the compute service. Now we also have the notion of a network node, which is responsible for the layer 3 networking. Now we've been working very hard upstream to make sure that the layer 3 agent and Neutron actually are capable of running in highly available fashion. Obviously, running them both together, making the writes to the same areas to the database is not that straightforward thing for Neutron. So we've been working on that for upstream and making sure that it's capable of running. We got a Neutron fixed, or actually the upstream community got Neutron fixed. Reddit obviously is a part of that. And we are now heavily investing to make sure that the layer 3 agent also is capable of running in a highly available fashion. So for OSP5, we're going to release the network node as an active-passive solution. And once it's committed, once it's fixed upstream, it's also going to we're going to benefit that in OSP5 in OpenStack platform 5, the Reddit distribution. So that's the most common use case for OpenStack, where we have the controller plane and we have a bunch of compute nodes, right? So with this layout, to make a highly available solution, we use 3 controllers layout and compute nodes. And this will come out of the box with OSP5. Okay, remember the screenshots we've seen before? This is the default layout. In addition to that, we also support distributed layout, right? Because in many cases, you want to have those components external. Not necessarily you want to have HA proxy as a load balancer. Sometimes you want hardware load balancer, or you want a different database or a different storage store. So that's supported by reference architecture today, and we are working also to make sure that this is supported also from the deployment tool project stay-puffed. So to conclude, we have everything very simple and easy to deploy. Single selection button. You just choose your controller nodes. You choose the services you want to make highly available. We use pacemaker and HA proxy to serve highly available services which are stateless. That enables that. And Galera DB replication for the data store with the persistent data store, and RabbitMQ for mirror queuing for the queuing layer. By the way, this slide will be available also to download after the summit, so not necessarily have to take pictures of it. Questions? Yeah. Can you ask louder? Yes. So we are working on everything upstream first, and only then it's going to go on RHEL OSP. So today, Project Stay-Puffed is upstream as part of RDO. Okay? And in June, we're going to release OSP5 with this as the enterprise solution. Yes. So, what's the name of the upstream project? So the name of the project is Stay-Puffed, which is a plugin on top of Foreman. So Foreman is a generic deployment tool that we use to deploy OpenStack. And Stay-Puffed makes sure that the Foreman installation is specifically designed to deploy OpenStack. Yes. Which? Yeah, go ahead. No, so there's only one running node, right? And upon failure, the service itself does not store any data, right? So the data is stored at the database layer. So there's only the failover timeout you're gonna experience, but other than that, there's no data loss. Yes. Yes, so yeah. So
can the DHCP client be set, DHCP agent be set up through the compute nodes instead of being an active passive on the network node, which I run currently today per OpenStack guidelines?
yes, so the DHCP service can run in a highly available fashion on top of the compute nodes themselves. That's just design we chose to make sure that to make the network node to be together, because in that scenario the DHCP node would serve the nodes themselves, right?
I've done a scenario where I can kill off a DHCP node and a DHCP agent on any of the compute nodes, and one of the other agents will happily grant it. And I've seen white papers on it quite a bit.
Yeah.
It works beautifully.
Yeah.
I'm thinking about it, what we currently do for ROS 4, so this is ROS 5, but ROS 4, we had problems getting active neutron servers. We were going to have to pass with neutron servers in ROS 4, and so then the DHCP became a problem in ROS 4.
I have no issues there.
What distribution do you use?
ROS 4. The other thing is one thing, do you change the ARP3 up on the L3 agent, so when the pacemaker flip happens, we're not waiting for the 30-second re-arc or the gratuitous re-arc, because that would cause a network outage to the user.
Yeah, I would prefer to take that offline. I don't remember about the configuration itself. Yes.
Last I heard on the layer 3 agent for in upstream, the active passive failover takes a minute or so because it has to delete all the routes and then recreate.
Yeah, it has to clean up. So yeah, so today we have the cleanup as part of the form of the Puppet manifests, but obviously we seek to have an active solution and working on that on upstream. So, yes. So when exactly is the active network node coming? So I cannot commit for exact date, but we're working on that upstream first, and only then making it available downstream. So probably that's come up in an async release for OSP, but there are no commitments yet. Sorry? Yes, so yeah, that's going to include not Satellite 6, but the version that Satellite 6 is going to be based on upstream.
So the plugin that we're using today, there is no Satellite 6 in production, so we're shipping a full liquid run OSP, and then when Satellite 6 comes out, the plugin will be available to use Satellite 6.
Yes, the guy in back. Yeah, so a lot of the stuff is going to be configurable through the host groups in Foreman. That's not going to be presented in the wizard UI, but you will be able to configure a lot of the stuff from the host groups side in Foreman. Yes.
Are there a lot of customers running OpenStack in production today?
Are there a lot?
Sorry?
Can you repeat that?
Are there a lot of customers running OpenStack in production today, or is it more of a
Yeah, well, there are some production environments running today, mostly built their own high availability solutions, basically, or writing that in Puppet, or using other configuration management tools, or just building the things by hand. But yeah, there are some environments running in production today. Obviously, high availability solution is extremely important for those. Yes. Right. So RHEL OSP 5 is going to support RHEL 7 and RHEL 6 as well. So first stage, we're going to have MariaDB, which is part of RHEL 7. We're going to use that. And that's going to be supported in sometime in the future for RHEL 6 as well. Any more questions? Yeah.
Well, so plugins for like Neutron, let's say I wanted to run NSX, VMware's NSX Neutron plugin. Will all of that then be coordinated via host groups as well?
So that's going to be coordinated from the Neutron server is going to be coordinated from Pacemaker, but the Nicere stuff, the VMware stuff, is going to be coordinated by them. They're going to have to.
But calling that plugin with my Neutron configuration, will that then be done via a host group with local parameters, or can you configure that with the format plugin?
Well, if you can approach after that, we can discuss this. I'm not sure I'm understanding the question. Yes.
People have already deployed those before. Is there going to be a migration or an upgrade path?
Yeah. So there is a migration path, but it's not fairly straightforward. It's not just point and migrate at this point at least. Yes, so we have a supported path of migration. It's not fully automated yet. Yes?
I wanted to touch the topic of scalability and capacity planning. This consists of two smaller questions. A, which OpenStack services are single-threaded and which can multi-thread? So this is one thing. And the second thing, which services are stateless and which services are not, or load balancing?
So it's fairly complex to answer, because some of the services already consume Apache, which is multi-threaded. Some of them don't consume that yet. So it's. Which ones do and which ones don't? Well, we can take this offline. Just approach after the session. Any more questions? All right, thank you guys. I'm here if you have anything in addition to that.